So we've been tasked with creating Risk Catalogue in order to eliminate rework required for risk register creation for new projects, keep the record of valuable expertise data essential for project analysis, as well as to create comprehensive repository of risk and their mitigations. And that's in a nutshell, and you can read the rest from this slide. So the background and context. In our approach, we looked at the need, features required. Then we have chosen a most suitable database. And I'll talk a little bit about our approach. So in terms of needs, I already mentioned that this is supposed to be a project-agnostic risk catalog with universal use across organizations. Required features that we looked at is scalability. So for our solution to be able to to handle increasing amount of workload, and also interoperability, which is to make sure that various system components work seamlessly, regardless of their differences in protocols, hardware, or software. SQL have been chosen due to its comprehensive features and very wide use and versatility. And within our approach, we looked at collection, storage, analysis, customization of data, and updates, which we are going to talk a little bit more about in the next slides.
Okay, so the risk catalogue will be a vital source of information to stakeholders with the ability to filter to specific requirements. The risk catalogue will provide a range of functions, as you can see on this slide, which includes data consistency, which will be improved as the data within the catalogue will be accurate, up to date, and consistent with the actual state. Performance considerations have also been taken into account, so the catalogue is designed to ensure smooth running of the database, especially during peak times. Another consideration is scalability, so the catalogue is designed to scale as the number of databases, tables, and other objects it catalogues grows over time.
The database has to have value and has to have useful need for the organizations. So to do that, we've allowed for customization ability, so you could be able to add more fields to the database. Organizations can also customize existing fields, creating more risk categories and taxonomies to align with the specific needs and terminology of their organizations and projects. The benefits of this would include improved decision-making, efficiency, visibility, and transparency. And then there's that value of enhanced collaboration and compliance as well.
Talking a little bit about the database itself, it's set up to allow for users to quickly sort through a large volume of data and find previous risks from other projects to help them inform their new projects. So this is why SQL was chosen. It will be able to deal with that very well, regardless of whether there's 100 risk entries or 1,000 risk entries. As a couple of very simple examples, we can look for projects that are just internal to the company, or we can look for projects that are internal and are part of the operations and maintenance division. It's very easy to narrow down based on the various data points that we have, because there's about 34 generic data points within the data set. This means that you have quite a wide variety of generic data to be able to sort through in order to find projects that are most appropriate to what the risk managers are after. The implementation of this, whilst the database currently exists, there are other tools that need to exist around it. So we know companies will currently have systems regarding how they store their risks and how they look back on them over time, but they're probably not in exactly the format that you would need to put them into the SQL database. So first and foremost, a set of input tools is required in order to convert what they currently have into the new generalized format of the SQL database. This is relatively straightforward, but it will require some Power Apps or Python knowledge from the company in order to actually make that happen. Now, as we've just shown, you can just query the database directly, but ideally you will want some output tools that form those queries automatically for you and allow users to just access the database without actually having to know SQL query language in order to actually interface and get what they need. In terms of customization, you can add more columns whenever you need to the database. What we've provided at the minute is generalized and project and domain agnostic, but we know that companies will be needing to add more as time goes on. As previously mentioned, we have provided documentation already for what is currently within the database to help guide the companies in order to use the database as intended, but to also make it as useful as possible with the columns that currently exist. So they could pick up the database as it exists, add nothing to it, and actually get some benefit immediately. Moving on to the questions that were provided to us, asking about what sort of skills and capabilities will organizations need. I already touched upon this a little bit, but system admins within the organization will actually need to know how to host SQL databases and know how to maintain one. This isn't an especially high bar, but it is a bar, and some companies will need to learn that. For the users, if you don't have a front end, your users will need to know how to use SQL queries, but ideally, again, a front end would be developed beforehand to make that work. How we ensure that data is entered consistently between organizations, we've already talked a bit about the metadata sheet and how that should give guidance. A lot of the data within the database also has pre-filled enumerated options within it. So there are only certain entries that are valid for a number of the data points, which means you get some consistency by just forcing people to choose from a select list. And individual companies can change that list. But again, the metadata sheet will suggest that you keep this the same, or that you at least keep some kind of enumeration for those fields. In terms of how organizations can see the value in a solution before they use it, we've already covered this in part, but again, the production of input and output tools, even as example input and output tools, would be the main step so that companies can in fact see an entire pipeline from taking their current risk data to having this overall organized singular risk database.